Okay, in this video we're going to do some applications of trig functions, and we're going to start off with trying to figure out what the equation of the function is given its graph. Then we're going to try and translate a given function from a cos to a sine or sine to a cos, and then we're going to do a couple word problems from the textbook. So before we can figure out what this equation is here, we need to know the form of a trig function with its transformations. So we've got this, so y equals a times sine or cos, depending on what we're going to use, and then times k x minus d plus c. C is going to come from the axis. A is going to be the amplitude, so the distance from the axis to the maximum or the axis to the minimum. And the sine is going to depend on whether we use sine or cos and which one we use. And d is the horizontal transformation. Okay, so we've got some horizontal numbers on here to figure that out. And k is going to come from first identifying what the period is. Okay, and the horizontal stretch factor is 1 over k. So if the period of sine or cos is 360, then what this does is it changes the period to 1 over k times 360, or just 360 over k. So let's get started. So we know that the minimum is -1, the maximum is 6. So from that, we can tell that the amplitude, or at least the absolute value of the amplitude, is going to be the maximum, okay, minus the minimum over 2, which is going to be 7 over 2, which is 3.5. Okay, and the axis, well, that's going to be y equals the minimum plus the maximum. So 6 plus -1 all over 2, which equals 5 over 2, 2.5. Okay, so we know that this axis now is y equals 2.5, and that's where that is there. Okay, and that makes sense because if you go up 3.5 from -1, you get 2.5. Go down 3.5 from 6, you get 2.5. So it's right in the middle. Okay, and then so now we've got this equals the c value, and we can look at this function and say, okay, the starting point of, say, a cos function is here. The starting point of a sine function could be here for negative sine because it goes down, or here for positive sine. It looks like from this it might be easy to start with the cos function. We're going to look at the sine function as well, though. So a cos function would start at 3, so it's been horizontally translated 3 forward. So if it's been translated 3 forward, and then it's going down, that's a positive cos function, then d is going to be 3. So it's going to be x minus 3 here. Now the period of this is going to be determined by figuring out what k is. So we know that from the maximum to the minimum, we've got from 3 to 11. And that's a distance of 8. Now that's not a full cycle, that's a half cycle. So from here to here is a half cycle, then back up would be a full cycle. So we could fill this in here. If this is a distance of 8, then this is also a distance of 8, which would make that 19. And this would be the period, t equals 16. Okay, so now we've got t equal to 16, which equals 360 over k, which I showed you up here. Okay, and now we can look at figuring out what k is. So from this, we then get k equals 360 over 16. Okay, and does that reduce? Well, 360 over 16 equals 22.5. Okay, so it's a nice decimal number, so we can use that exactly. And now we can figure out what this function is. So we're going to use positive cos, because we're going to start here. So y equals 3.5 cos of 22.5 x minus, so I'm pushing it forward, so it's going to be x minus 3, and then plus 2.5 at the end. Okay, so that's one cosine graph. If I wanted it to start from the bottom, that would be a negative cosine graph, and it would have been translated forward 11. Okay, so, or y equals negative 3.5 cos 22.5 x minus 11 plus 2.5. And you could check this with graphing technology. These two graphs should look identical. Okay, if we wanted to use sine, well, let's go back up here. If this is the maximum, this is the minimum, sine is going to happen right in the middle. So in the middle of 3 and 11, so if that's 8, then half of it's 4. So 3 plus 4 is going to be 7. Okay, and that would be a negative sign. Or 3 minus 4 would be negative 1. And that would be a positive sign. So the amplitude and period and all that kind of stuff stays the same. So we could just write this in here as y equals, if we want the positive sign, we're going to use, the sign has been translated back 1, so I'm going to use x plus 1 in this part here. So it's going to be 3.5 sine 22.5 times x plus 1 plus 2.5, or y equals negative 3.5 sine 22.5 x, and in this case it's a negative, so it's going down, so I've translated it forward 7, so it's going to be x minus 7 plus 2.5. Okay, and that would be 4 different functions, 2 sines, 2 coses to represent this one. Okay. Now, say we want to convert this function to a sine function. Well, in order to do that, we have to look at how to convert sines to coses and coses to sines. Okay, so if we look at the two functions, here's a sine function, and here's a cosine function. Okay. Now, if I want to convert a sine to a cosine, I'm just going to move this back a quarter of a period. If I want to convert a cosine to a sine, I imagine it back here, and I'm going to move the cosine forward a quarter of a period. All right, so there's a full period, half period, quarter period. Okay, so basically what we've got here, oh, and we can do it, we can convert a sine to a negative cos. If we look back down here, we can convert this sine, if we move it forward a quarter of a period, we'd have a negative cos. Okay, and if we moved this back a quarter of a period, we'd have a negative sine as well. Okay, so look at this sine to cosine. We translate back 1/4 of a period. So basically in the function you'd have theta plus 1/4 the period. Okay, cosine to sine, you'd translate forward 1/4 of a period. So you'd have theta minus 1/4 t when you put it into the function. Okay, so you always do the opposite when you put it into the function. So now for this one, let's say if we wanted to write sine in terms of, so cosine theta then would equal sine of theta plus 90, okay, because 90 is 1/4 of a period of the sine function and cosine function. Or we could write sine theta equals cosine of theta minus 90, because I'm going to move the cosine function forward 90, to get a sine function. Okay. So with this function now, what we're going to look at, well, first, this is not factored inside, so we have to factor that in order to figure out what the period is and translation, all that kind of stuff. Okay, so we're going to rewrite this as y equals -3 cos of 5 theta, but I'm going to put brackets there. So 5 times what is 130? Well, that's going to be 26. Okay, and then plus 4 at the end. So to make this into a sine, we need to first figure out what the period is and then move it 1/4 of a period. So the period equals 360 over k. K is 5, which equals 72. Now we can figure out what 1/4 of a period is. So 1/4 t equals 72 over 4, which is 18. Okay, so there's the amount we're going to shift it by. So what we do here now is we write this as -3. Okay, so -3 sine of 5. Now this represented the angle before. So now I have to add or subtract 18 to that. Because we're taking a sine and turning it into a cos, we have to add the 1/4 of a period. So 5 times, I'm going to do a double bracket here, theta plus 26 is the angle, and then I'm going to add 18 to it. Okay? And then plus 4 at the end. Now this I need to work out as -3 sine 5 times theta, so 26 plus 18 is 44, okay, plus 4, and that's our function. Now if we want it in the original form where it's not factored inside, we just expand that out, -3 sine 5 theta plus 5 times 44 is 220 plus 4. Okay, so that's to get cos into a sine. We translated a 1/4 period forward. Or we could take the sine, if we wanted to make it into a positive sine. So instead of -3 sine, we could do a positive sine. So if we take it and transfer it the other way, so back a 1/4 period, we would get, forward a 1/4 period, we would get the positive sign. So another function would be, so to go the other way here, if we did minus 90, that would be a negative cos. So this was already a negative cos, so we could change it to a positive sign by doing minus 90. So 3 sine 5 theta plus 26 minus 18 plus 4 equals 3 sine 5 theta plus 8 plus 4, which equals 3 sine 5 theta plus 40 plus 4, and you could put that into graphing technology. You graph all three of those and they'll look exactly the same. Okay.